Hello, everybody. Welcome back to the short lectures in physics. The topic for discussion in this session is errors in measurements. As you know, the measurements are generally done with instruments, measuring instruments, and every measuring instrument, will have some capability to measure the minimum possible uh, values to the extent possible. So this minimum possible measurement with each instrument is known as the least count of the for the particular instrument, and it is also known as a vernier constant. And any measurement uh, cannot be very close to the actual value, but it can be close to the value. It is not the actual value we can measure. Absolute value cannot be measured because of various reasons. Uh, the actual value cannot be obtained, but we can approach to the value which is very close to the actual value of the physical quantity what we are going to measure in that. So if you take vernier calipers, we are talking about least count, that is minimum possible measurement with any instrument. If you take a vernier calipers, we know that we are using in the lab, and it has got one main scale just like ordinary scale, and with centimeters and millimeters graduations on that, and a small vernier scale sliding over that, which is having some number of divisions. Generally what we see is 10, it may be more than that also if it is a bigger calipers. And the least count of such vernier calipers is given by the ratio of the smallest division on the main scale, that is 1 millimeter, and the number of divisions what we made on the vernier scale is the least count. That means 1 millimeter by, suppose if there are 10 graduation divisions on the vernier scale, then 1 mm by 10 is 0.1 mm is the least count. If the divisions are 50, 1 by 50, that is 0.02 mm is the least count. That is the minimum possible value with that particular calipers instrument. So we can, that's how we can increase the least count and the capability of the instrument to measure the smaller values of measurement dimensions by increasing the divisions on the vernier scale. If it is a screw gauge, as already know, it is a shaft-like thing. There will be a main scale on the circular shape, and there is a screw type circular scale, which is when you rotate it, it moves from one edge to the other edge of the main scale. So on the circular scale there will be number of divisions, and on the main scale, as you know, normal scale, I think every millimeter graduations are seen. So in this case, screw gauge, it is defined as the pitch because it is a screw driven machine. So pitch is associated with this particular screw gauge instrument. Pitch is nothing but the distance moved by in one rotation. When you rotate the screw, it moves on the main scale through some distance. So minimum. Suppose if you move 10 rotations, it moves through say 10 mm on the main scale. Then the pitch is given by distance traveled by number of rotations. That means 1 mm, if 1 mm is seen in one rotation, then 1 mm by 1, that is 1 mm is the pitch, and least count is given by the ratio of the pitch by number of head scale divisions, that is 1 mm by, suppose if there are 100 divisions, we get decimal less, that is 0.01 mm capability. If you increase the divisions on the circular scale, again least count can be increased. So that's how for any instrument, even LVDT or any instrument, it has got its capability to measure that depending on the calibration what we are doing. And now we learned some terms which are about accuracy, precision, and reproducibility. Accuracy, of course, everybody knows. How much is the measured value is close to the true value, actual value. Precision. Suppose if a scale is able to measure 1 mm, then the measurement can be within plus minus of that minimum possible measurement. That means plus minus half mm, plus minus 0.5 mm. It can be 1.5 mm or 0.5 mm like that. Accuracy is half of the minimum possible measurement. That is the precision. So if you are able to measure the value precisely, same value if it is able to give, then we say it is the smallest value, whatever is possible to measure, then we say the instrument is more precise. So as small value as possible, if it is able to measure, we can say it is precise machine. And coming to reproducibility, when you do the measurement number of times, then if the instrument is capable of giving same reading under same identical condition, the means temperature, environment, and other things are not changed, then if the instrument is able to give the same reading on repeated number of measurements, then we say the instrument is reproducible. That means anytime you measure, you will get same reading under identical measuring condition. That is important. So these are about some terms which we need to know in the measurements uh, while doing taking measurements. Then, of course, measurements are there. We are taking instrument is there, everything is there, but still we'll end up in some arriving at the readings. We have some errors in the readings. So these errors are systematic readings and random errors. Systematic errors means they occur due to known reason. We know the reason why it is why the error is coming. So generally that occur due to known reasons, and generally the improper design of the instrument, or when you are calibrating the instrument, the procedure is not properly done, then also these errors will come. So we know where the error is coming. And taking readings wrong, we are seeing something but noting down something like that, and inaccurate formula. So this reading will be same. So how many times you do, you will get same reading. So we are difficult. It is difficult to identify that there is some error unless otherwise you know the reason for it. Once you know the reason, you can apply counter correction for that, and then you can avoid the systematic errors. But random errors are different because we don't know the reason for which it is happening. So it is difficult to eliminate unless we know exactly where the problem is coming. So what you have to do when you cannot do anything, then you take number of measurements. Means when you do number of measurements of the same physical quantity, you will get different values because the error is in random conditions. So you take large number of measurements and then apply the statistical methods to arrive at the actual value of the physical parameter, whatever you are measuring. Then other one is grass errors. These grass errors are generally the operators, the person who is taking the readings is not well trained, or he is very careless. This kind of things will be there. Or when somebody is telling, somebody is noting down the reading, so readings are taken in a wrong way, and wrong calculations, wrong data entry. All these kind of things are together put together and comes under grass errors. That is due pure sheer negligence of the person who is taking the measurements. So proper training to the operator or the person who is taking readings can minimize these errors. We can minimize these errors. So we are talking true value. So as already mentioned, because of various reasons, the actual or true value of the physical parameter, whatever you want to measure, is difficult to get it. So what we have to do is you can take a large number of measurements and apply the statistical methods to arrive at the true value. So the mean value of large number, that means when you do number of measurements, suppose 100 measurements are, you add them and then by 100 is the mean value. So under identical conditions, of course, the measurement should be done under identical conditions, number of measurements, and then take the mean value that we can approximately consider to be the true value. So x mean value of the parameter x is given by summation of sigma xi is number of measurements, 1 to n measurements we have done, x1 plus x2 plus x3 by 3. If you do n measurements, x plus x2 plus up to xn by n, xi sigma xi by n is the x mean value. So that we can consider for approximate value as the true value, approximate true value. Then some more instrumental errors are also there. That is, they are mechanical faults like zero error. When you take screw gauge or calipers, for example, like our favorite measuring instruments, most of us know. So the mechanical fault is most of the instruments we have faced in the colleges that zero of the main scale error, main scale is do not coincide with that of the vernier or head scale. So that difference between the both zero marks, the distance between the both zero marks is the zero error. So if you see the list count is known, then when your zeros are coinciding, whatever the main scale is coinciding with the vernier scale, that product number into list count will give you the magnitude of the zero error. So zero error has to be corrected when you take the actual value of the measured value. So if the vernier or screw gauge, if the vernier zero mark is seen on the right side of the main scale, then the zero error is said to be positive. Otherwise, if the vernier zero mark is seen on the left side of the main scale zero mark, then the zero error is negative. So zero error, you take the proper the different zero error magnitude of the zero error you know take with proper sign, then that zero error has to be subtracted from the actual value after taking the zero error with the proper sign. If it is a minus sign, it will get added. If it is plus sign, it will be subtracted. That's what it means. Then backlash error. Sometimes what you do, you move the measuring instrument in one direction, and then suddenly you find there is something wrong, so you want to move back. Suddenly you're reversing the measurement direction, then this backlash error inevitably enters into the measurement, whether vernier calipers or screw gauge or whatever it is. This is also a design aspect because most of larger types, the the threads of the instrument or the sliding of the caliper, they get undergo wear and tear. That is, the surfaces will get damaged, and then the threads of the screw in the screw gauge will get spoiled. So immediately, if you are turning one side, no problem, they will be in contact, and when you want to turn back side, there is a gap between the screws, or there is a backlash. So because of that, the reading is affected. So this as far as possible, you move the measuring direction. Try to maintain the measurement direction in one direction, unless otherwise it is essential. Or if it is essential, then wait for some time, allow some time for the thing to get sorted out, and then move back. As far as possible, take the measurements by moving the screw in one direction only, by moving the vernier scale or a circular scale in one direction only. Then we talked about the mean value, statistical mean value, and the actual value. Then the measured value also we have. True value we want to get it. So measured value is there, and when you by doing number of measurements, you got the mean value also. So the difference between the true value, any particular, suppose a fifth measurement is there. 10 measurements you have done, and you got x mean of the 10 measurements. That is x mean. X measured is a particular measurement. So the absolute error for each measurement can be obtained as delta x, that is called absolute error for individual measurements. Delta x is equal to x mean minus the measured value of that in that particular time. Similarly, arithmetic mean of all such absolute, there are 10 measurements you have done, so all the 10 measurements you take, and then sigma xi by n is delta x mean, that is mean absolute. All such mean absolute 10 measurements you have done, for each measurement you calculate the absolute error and find out the mean absolute average of all these get mean absolute error. So if mean absolute error and the absolute error both are there, then you get the value can be obtained as a physical quantity of x can be obtained as x mean plus delta x mean. X mean is the mean value plus delta x mean will give you the true value. So relative error is delta x by x mean. Then propagation errors are means suppose you want to find out some physical parameter which involves measurement of more than 2 3 other physical parameters. So each one each measurement has got its own errors. So all the errors of individual measurements should be considered in arriving at the final physical quantity, error associated with the final physical quantity, and the expressions whatever you are using also. Suppose v is equal to u plus at. So to arrive at final velocity v, what is the error involved in the measurement of velocity itself, and what is the error involved in the acceleration measurement, and what is the error involved in the time measurement. All the three should be taken, and the proper mathematical operations involved in this estimation are also to be taken into account to arrive at the propagation errors. So any measurement when you do, one has to be cautious about these errors and then present the actual value as close as possible to the true value. Hope this finds you have a clear understanding about the errors, and then next session we see how to deal with the errors in algebraic equations also. Bye till then.